Hi class, my name is Lourdes Nuno. I am presenting Project 1 in our Business Calculus class. Let me see if I can share the screen here. Okay, got it to work here. Let's show you here. And right here, we're going to start with 1929 right here. The stock market actually crashed. So our economy dived into a recession. As you can see from the graph here, the line is going downwards, and as I stated down here on the graph, as the slope goes negative or it goes down, it indicates a contraction, which is a recession. And let me go to the next screen, which is in 1930, there was a tariff that was implemented, which also caused further spiral down of the GDP. This was a tariff that was implemented, and it actually didn't work. There was a retaliation from other countries, so they put tariffs on our items, so we further spiraled downward. So let's go to the next screen or the next. So here in 1932, Hoover implemented tax hikes so that we can pay off expenditures, but it seems like it did not. Apparently, it didn't work. But it looks like our economy is rising a little bit because the GDP is actually going up. Let's go to the next screen here. Yeah, see the GDP graph reflecting upward and positive slope indicates economic expansion. So we're actually rising, or we have growth. So perhaps that's he saw that there was indications that our economy was growing. So perhaps that's why they implemented the taxes. Also, I believe in 1933, there was a New Deal for protections of banks. So they had to create better policies. So this brought more reassurance to the American people. So our economy with this New Deal started rising. And let me see. And actually here in 1936, where it seems like we are going back up right here on number 7, which is 1936, FDR implemented tax hikes on corporations, which brought us into another slight recessionary period right here where this parabola is. And from there, 1938, the recession ended, so our GDP started rising and rising. And the last area right here, actually in 1939, there was World War II. So that's my description for the GDP. Okay, let's move to the next screen. Here we have in this screen, I actually broke down each piece of the graph, which is gonna come. It's gonna make up the piecewise function graph. So what I did was I just sectioned off each section that pertains to each line that we need to be able to create a separate calculation. So and we need to be able to visually see what the line looks, what each section is, so we can determine if it's a line or if it's a parabola or whatever kind of equation we need to use. So let's start with this one, the one right here. That's like the first one from 0 to 3. This resembles a line, so we're going to use the line model, and the inequality notation would be 0 is less than or equal to x, and x is less than or equal to 3. And I also showed you the domain, which is 0 to 3 here. And the second piece, it resembles a line as well. This is I'm going to be using the same types of calculations or the same process that I use for all these reds here is 1, 2, and 4 pieces. They're all, if you can see, they're all lines. So we're going to be using the same process to calculate these parts. And right here, we have the parabola. This resembles a downward parabola right here, this loop here. And we are going to be using the quadratic function for this. I also show the inequality notation, which is the 6 to 8, and the domain is 6 through 8. Over here, I also put the domain, which is 3 to 6, which is here 3 to 6. Okay, let me hide this so we can see the full screen. Oh, that's okay. Okay, let's go to the next page. Right here, I am showing you now. Right here, I show you which pieces we're going to be using all of these calculations. We're going to use piece 1, 2, 4, and we're going to calculate a linear equation. We start with all the information given, which is these points right here for section 1. Piece 1, these are the points that are given. This is x and y. So we have 2 points, like the starting point and end point. And for section piece 2, we have the points, first point and then the second point, and then the piece 4, which is the last tail end of the graph, is these points as well. So what we need to do is we need to create a slope intersect form. This portion is what's going to go into our piecewise function. And in order to get there, we need to, well, we actually, we might have x and b, but I believe we need to find the slope because the slope is needed. And in order to find the slope, we use the slope of a line function or calculation here, which is y2 minus y1, x2 minus y1, and so forth. And then after that, we get the slope, then we can use the point slope form. And after we have the point slope form, that we can just arrange it into slope intercept form. So let's go to the next screen. I'm going to show you the calculations for each piece, how I did it. Let's go there. So next one. Okay, so this is piece 1. This is the x and y points. This is the first point and then the second point. So step 1 is to find the slope of a line, which is, let me move my screen a little bit here. So we have the y2 minus y1, x1 minus x2 minus x1, and this is what we get. We get a negative 100 for the slope. And I want you to note that negative slope equals falling as x moves left to right. And that means, maybe I should have put a picture here, but it coincides with what this says here. We have a negative slope that falls as x moves left to right. Let's go back to that screen that shows. So right here, it's falling from left to right. So that's what the negative means. Okay, let's go back to that screen. Oops, too far. Next one. And then after that, we found the slope here. We plug it into our point slope form, and which is right here. And we use y minus, and then we're going to use the first point here where this is the x and this is the y. So we're going to plug in those numbers and do the calculations. And we end up with this number here, which is in slope intercept form. And this is what we're going to input into our piecewise function for this piece right here. So this is piece 1, and I did the same thing for piece 2, which is finding the slope. Oh, and this one, please note that this is a positive slope. See, it's a positive number, so it's rising as x moves left to right. So it's rising instead of going downwards. So I did the same thing here and ended up with with this calculation here, which is going to go into our piecewise function. Next screen is, so our piece number 4, I did the same thing. Same kind of calculations, and this is what's going to go into our piecewise function. Next screen, here we have piece number 3, which is a different shape. It is the parabola. We must calculate a quadratic equation. We start with the information given. The information given are 2 points on the line, the beginning point and then the ending point, and then also the vertex, which is HK. And in order to create or to get that calculation, we need to use vertex form, and vertex requires all these numbers. So we have HK and we have 2 points. So what we're missing actually is this A right here. So and also I want you to note, we need to solve for A. We can use the vertex form to solve for A, since we have all these other numbers here. We can just punch those in and do the calculations. I will show you on the next screen. So note here is A, the leading coefficient opens if it opens upwards when A is greater than 0, and it opens downwards when A is less than 0. All right, let's go to the next screen. Next screen shows you how I came up with the quadratic equation. So we have your X and Y points here. We have 6 and 1,000, 8 and 1,000, and H and K is 7 and 1,100. So step 1, solve for A, use the vertex form. So I'm just going to plug in, I'm using this one. I'm using the first point, which is the 6 and 1,000. So we plug in all the numbers there, and we're going to plug in the vertex, which is the 7 and 1,100, and we have A there. So we'll solve for that, and we're going to subtract we're going to subtract 1,100 from this side, or yeah, from this side, and subtract it from both sides. And then we're going to do our calculation here. And also note, A is less than 0, confirms parabola opens downward. Okay, so this is our ending product for the A, which is -100, which it confirms that our parabola opens downward. As let's go back to that one screen, we can show you that it opens downward. It opens downward right here. All right. I should have put a snippet there, but I didn't. Okay, so for our next step is to put in that A into our vertex form, so we can get our formula here. So we distribute these numbers into here. We add and subtract as we know to do. So our final piecewise for piece number 3 is this calculation here. So let's go to the next screen here. Let me see if I can put this down here. I put little screenshots of all the pieces here, and this is our final. This is my final piecewise function. So all I did was I put in the calculations that we came up with here for each piece as they go down, and then the domain is right here also. And that's how you do a piecewise function. All right, let's go to the next screen, which is our limits. Okay, so we are moving to task number 2. So this one, we have to apply concept of limit to solve a business related problem. For question number 1, they ask what are fixed costs and variable costs. So a variable cost would be something like material, which is the polyurethane that a surfboard uses. That price may fluctuate. And then we have like fixed costs. Fixed costs are like overhead and administrative costs. That's for question number 1. Question number 2, for a graph below, average total cost. What is the average total cost of which is the average total cost of one item based on the output, implies the lower the output. Now let's look at the graph here. The graph here for the average total cost, this graph implies that the lower the output here, the higher the average cost for the item. So that's what basically the average cost it means. For another question on number 2 is what is the difference between average total cost and total cost? The difference is that average cost is basically your price of one item, and it's taking the price of taking the total cost divided by one of the items, so you can get an average of what the cost is for each item. And then total cost is, well, the calculation that the formula that we use to get the total cost. So it's a whole. It's all of the items put together. That's the difference of those two. Now let's go to the next question, which is question number 3. Here we have so based on the graph, my mathematical expression for the limit of the average cost function, I wrote the limit of the average total cost. X is infinity because it just keeps on going here down here next to close to the 0. And the next question was they want to, or 3B, they want to know what is the limit of the graph. I can see right here that it runs along the 0 on the average total cost axis, which is the y-axis here. So it runs along the 0. So I chose 0 based on my observation here. So this is what I came up with. Let's go to the next screen. The next question. So number 4, I believe, according to the graph here, if the company produces a large amount of surfboards, their cost will be basically 0. Yes, and for number 5, I believe that the company does reach economies of scale. I'm sorry, since the line graph runs along just along the 0. So I believe, yes, they do reach economies of scale. Thank you. Oh, and this is my references here. Thank you, everybody.